Hello guys, so today we'll be doing LeetCode question 45, which is jump game 2. The question is, you are given a zero-indexed array of integers, nums, of length n. You are initially positioned at nums position 0. Each element, nums position I, represents the maximum length of a forward jump from index I. In other words, you are at nums position I. You can jump to any nums I plus j, where O is smaller than, where 0 is smaller than or equal to j, and j is smaller than or equal to nums I, and I plus j is smaller than n. Return the minimum number of jumps to reach nums n minus 1. The test cases are generated such that you can reach nums n minus 1. So we're assuming that you can always reach the ends pretty much. So example, nums array 2, 3, 1, 1, 4, output is 2. This is because the minimum number of jumps to reach the last index is 2. Jump 1 step from index 0 to 1, then 3 steps to the last index, so from 3 to 4. Example 2, nums is 2, 3, 0, 1, 4, the output is 2, because 2 to 3, again, jump 1 from 2 to 3, from 3 you jump 3 to 4. So the way we're going to do this is in the greedy algorithm, we're going to have 2 pointers, which are the end, which represents the current jump range you can get to, which is the end of the jump, end of the current jump, and the farthest, which is the farthest jump you can reach so far based on the current positions you've been at. And then we count the current jump. So let me give you an example here. So let's say we have array 2, 3, 1, 1, 4. We set the current jump value, which is equal to 0. Set the current end value, which is equal to 0, and the current farthest value, which is equal to 0. Then we loop through the array I, currently at 0, so we get 2, which is the index position of 0. So we know the furthest we can jump is to position 2. So we set the current furthest to 2. Then we check if the current I position is equal to the end position, then we have to increment it to the farthest, because we know we've reached the end. So we set, since I and E, which is end, are both 0, we set the end to the farthest, which is 2, and we know we've taken 1 jump, so we set the jump to 1. Now, we finish this loop, so we increment I is now 1, then we go to 3. Now from 3, which is position 1, we know the furthest we can jump is 3. 1, 2, 3, so the furthest we can go to is index position of 4. So we know it's bigger than 2, so we set the farthest as 4. And we don't trigger the if statement because E is not the same as I, because E is 2, I is 1, so we proceed. I is now 2. Now, the farthest we can go from here, from index position of 2, which is 1, is to position 3. So it's not bigger than the furthest, so we leave it as that. Now, I is equal to 2, E is equal to 2, so they're even. So we set the end as a current max, or is it so the end as a current farthest, which is equal to 4, and then we increment jumps. You know, we need to take a minimum of 2 jumps to get there. So then we increment I, which is now 3, which is 1, and again the furthest we can get to from here is 4, which is the same as the current furthest, so we leave it, and I is not equal to end, so we don't have to jump because we know we can get there with 1 less jump, because right now it would take to get here 1, 2, 3 jumps compared to previous one, which was 1, where's it? which was 1, 2 jumps. Okay. So now, as we've reached the end, so now we increment I, which is equal to 4, which breaks the for loop because we reached the end. So we have to return the current minimum number of jumps, which is 2, and that is our solution. So let's write the code. So again, we initiate the jumps, which is equal to 0, the current end, which is equal to 0, and the farthest, which is set to 0 as well. Now, we loop through the array, so let I is equal to 0. As long as I is smaller than nums.length minus 1, we don't need to jump from the last position of the array, then I plus plus. Now, we set the farthest as the max between the current farthest or index position of I plus the number at the position of I, which tells us how far we can jump from there. Then, if end is equal to I, then we set the end as the farthest and we increment the jumps. And then we return 0. No, sorry, not 0. We return jumps. Now let's run, see if that passes. Jump, param1, var 29, solution. Jump is not a function. Okay, smaller than nums of length minus 1 plus plus. I is equal to end. Jumps. Jumps. Okay, let's run. Perfect. Let's submit, see if it passes. As you can see, this is the faster time complexity. Time complexity is of O(n), so we're looping through the array only once. So the worst case scenario is O(n), and our space complexity is of O(1),